So I did manage to find what is wrong with our equation. So I think this should be dapat na pa ni siya ko andari constant value. So that should be 9.8 times 68.1. Then there is 9.8 times 68.1. So let's correct the table. So saan siya? So this should be 9.8 times 68.1. Ito ba? And it should be negative also, no? Yeah. It should be negative. Yeah, so let's just drag this one. So first iteration. Ito ano itong negative, negative. So let's drag this. Yeah. Let's copy the formula of the error. As you can see, and up to the third iteration, we did manage to get, I think, the second iteration, we did manage to get 4.77. Yeah. So, less iteration for the Newton-Raphson. So, let's proceed with the modified, the second method. So, same, no? Dito na lang ni nato. So, solution. Finding the value using second method. Then your iteration equation would be the same. Yeah, this one would be the same also. But the difference is your derivative of c sub I is backward, no? Or we could rewrite this one. So based on the second method, the new formula for the root would be f of c sub I, then c I minus 1, yeah, then c sub I all over yeah, the difference of the two. Just correct this. Okay, in such a way that your f of c sub I is this one, and your f of c sub I minus 1 is, wala nang exchange, 1. So, yeah. So simpler solution here for second method. So let's create now the table. So apply the iteration equation to get the root. Then this is second method. So yeah, think kanira itong pinahangganon. You need an initial guess. So for f of c sub I, let's copy the formula. Maybe this should work. So this one should be this one. I don't know. Ano di eh? The c sub I ito ba? Should be this one, and this one should be this one. Then we need to have at least two backward values. Function control x3 b. Let's say backward value is 11.5. Say -1. So the new root here should be based on this. So that is c sub I minus f of c sub I yes dayon times the difference between the two, so this one minus this one, then yeah, divided by f of c sub I, this one, ito na yung parenthesis, this one minus this one, close parenthesis, close parenthesis, then I think we're fine. So, paano siya? Then we will apply the f of c sub I here, 1 here, be 1. The error should be same formula. Yeah. Then copy format painter. Then you could drag this. Yeah, I think same with the Newton Raphson, no? But we still managed to find the root out from the two initial guesses. So let us try for a larger value. So let's try for 16. 16. Okay. Mas dali siya. So at second iteration, we did manage to get 14.78. How about here? Yes, we have 16. So that should be this one, 16. Let's just say this is equal to this. Equal to this minus 0.5. Yeah, mas dali pod siya. Okay. How about for modified secant method, last method? Okay. Modified secant method. So our iteration equation will be based on another formula, no? Based on modified secant method, which will be using a perturbation factor. So that should be your iteration equation. Kopyan lang tani para paspas. So that is C sub I minus, yeah, perturbation factor times, ito ba? C sub I dayon, sa ito dong i-confirm. Yeah, your perturbation factor. And let's insert a Greek letter, Greek letter sigma. It's 1. Dayon, your C sub I erase this one. Okay, wala na siya appeal. Then all over, yeah. F of C sub I, ano siya? Plus the sigma times the C sub I minus the F of C sub I. So, kana. So, where your F of C sub I is just the same to this one, then pwede ra na. So, let's try to apply this. So, apply this one. Then, this is modified secant method. So, let's just say that your initial guess again is 12. Then, we need to have a perturbation factor. That should be at least 0.01. So, I think we need to have at least another column here. So let's copy this one. So that should be F of C sub I plus the perturbation factor. Hindi siya makita. Let's just say the sigma. Okay. So first iteration, the F of C sub I is equivalent. So atong initial value would be 12. Then let's just copy this one. Let's just move the values here. Then same no kani siya to lang i-kopya. Then we just modify. So ci plus sigma, so kani siya ada na tog perturbation factor, which is this one. We have this one. Okay. Then in finding the new root, that would be c sub I minus open parenthesis perturbation factor times c sub I times f of c sub I close parenthesis divided by the difference between this one, yeah, and minus this one. I think naisay pa tong equation, no? Kanisiya, this should be times of the c sub I. Yeah. So let's just drag this one. I think we need to modify also this. Perturbation factor should be locked. So we need to put $sign. And this one, we need to put $sign. Yeah. Let's drag this one again. Copy the solution of the error. So let me itarong direct. This also. Yeah. Then dragging this one. So ang pinaka most satisfying part is to drag, no? Yeah. At the second point of iteration, we did manage to get 14.77. So more likely mas less na gud iyang computing ani kay yeah, we have second method at second point nakuha na rin nato, but there are two initial guesses, so meaning daghan gyapon ng solution, but for the modified second method we did manage to get less solution. So let's try to have one set of solution. Let's try an initial guess value of 16. So let's try 16. So yeah, same. Wala na pang highlight. Then after having this data, you could now have a conclusion. So pwede mo write down na the value of your C is this and that. No? And comparing to the bisection method, yeah, less na lang yun ang iyahang table, no? Less ang iteration. Okay. So that's it for open method. Thank you for listening.